Hi Year 13s. In this video we're looking at applications of differential equations. And so we have an example underneath here. So it's talking about how as time goes on a runner slows down. For one particular runner, this decrease is described by the differential equation here, where v is velocity and t is time. So our first question is saying if the runner is running at 2 meters per second at 5 hours, how fast is she running at 6 hours? So in effect this is asking us to solve this differential equation. And it's asking us to solve this equation using those conditions of 2 meters per second at 5 hours. So let's write this equation out in terms of dv and dt. So I can write dv is equal to negative 10 over root t cubed dt, and I'm going to write it as dv equals negative 10 t to the negative 3 over 2 dt. That will make it easier for me to integrate. So integrating both sides, I get v equals negative 10t, add 1 to the power, so negative a half, all over negative a half, and plus c. And just tidying that up a bit, we've got v equals 20 over the square root of t plus c. So we need to find what that c is, so we're going to use these conditions here. So when v is 2, then t is 5, then that will give us conditions for c, and so c is going to be equal to 2 minus 20 over root 5. So let's get our calculator out for that one. So 2 minus 20 divided by root 5 is that. We'll use the answer key for this later on, so negative 6.9 we'll say. And that gives us the particular solution that v is equal to 20 over root t minus 6.9. So the question's asking how fast is she running at 6 hours, so that means that we need to substitute 6 hours into here for t, and so we'll say, we'll bring it over here, shall we? So v at time equals 6 is going to be 20 over root 6 minus 6.9. So we'll put that into our calculator. So we'll have 20 divided by square root of 6 minus 6.9, so I'll go plus the answer because the answer is negative, and we get 0.2 meters per second. Sorry, 1.2 meters per second. Okay, so that's our answer for question A. Now we've got question B, which is saying when will she stop? Well, she will stop when velocity is equal to 0. So we're going to solve for the equation 0 equals 20 over root t minus 6.9, and so that's solving for when 6.9 is equal to 20 over root t. So 6.9 root t is equal to 20, so root t is equal to 20 divided by 6.9, and so t is equal to 20 over 6.9 squared. So get a calculator, we'll bring up that 6.9 exactly again, and we want it positive, so we'll times it by negative 1, and so 20 divided by that squared gives us 8.3. So at 8.3 hours, v will be equal to 0, so she will stop. So question C says, why is this model not appropriate after the runner stops? Well, you've probably got the idea here. It will go into negatives, and so the runner's not going to start running backwards once they stop. So because v becomes negative after 8.3 hours, it is not appropriate for the runner's speed after this time. So we're saying that it is appropriate up until then, but after that it's not really appropriate. Okay, I've got one more example to go through, and I'll do that in the next video.